we are going to talk about how negative numbers are represented. First, basically, if you have a minus x, we're talking about 8 bits. Okay? The bit count is very important in negative number representation. If you have a minus x, you have to convert that into positive x, 7 bit. This is all 7 bits now we're talking about. And then you take a ones complement of that, let's say a ones complement of that, right? That is basically, if you have 1 0 1, you flip everything to, if it is 1, make it 0, if it's 0, make it 1, right? That is the idea. So ones complement, then you add 1 to it, so you get the negative number representation. So why is this so like that, right? So first you need to understand that minus x can be represented as mathematically as 255 minus 255. How much is this? This is 0, right? Plus 1 minus 1, that's again 0, minus x, right? So I add a 0 and I add a 0 again, so that is not going to change my value. All right, and if you take this x, I'll put it in red. If you take this minus x and this 255 together, what happens is the ones complement, right? 255 minus x, in 8 bit the maximum value is 255. If you put minus, if you remove x, that's ones complement. Basically you are flipping, right? This is the ones flipping. All right, so we have that. Then we are left with minus 255 plus 1 minus 1. We take the remaining terms, right? So what you have now, so this one, you said this is ones complement, that's what we are represented here. We're going to take that's ones complement, right? So that is x1 complement, ones complement for that x number, right? Then you have my plus, I'm going to take plus 1, this particular one I'm going to take it here. So then we are left with minus 255 minus 1, right? So let me again write down. This one is coming from this and this minus 1, okay? And we took this plus 1 here. So it's kind of tricky, rearranging things. We are trying to rearrange things. There's no rocket science here. All right, so we have that. So we have, I'm going to take it here. So ones complement of x plus 1, 255 minus 255 is minus 256, right? But I hope you know this equation. We can rearrange that. So that gives you x complement, sorry, there's ones complement of x plus 1, and this is 0. If you add a 255, which is all ones, right, and you add 1 to it, it will always 0. 0 0 0 0 0 0 0. So that goes away. We are left with this term, ones complement of x plus 1. So that's what the negative numbers are represented as. Alright, so it's kind of clumsy, but let me again do it a little faster for you. So minus x can be written as 255 minus x plus minus 255 plus 1 minus 1. This is 1's complement. We're going to represent that as 1's complement of x plus 1 minus 255 plus 1. X complement, 1's complement, this is 0. That remains. So you always to find the negative representation of a number, you take the 1's complement of that number plus 1. That's it. This is the theory behind, the proof behind minus x representation. And here theory here, look at here, minus x plus x in general should be 0, right? So just add x to it. Complement 1 plus 1 plus x, right? Why is this 0? X complement, 1's complement plus x is in the 8-bit is 255, right? 255 plus 1, if you add, it will be 0. That's what you got. So there's a lot of proof for all these things, okay? Thank you.